So there is another technique in channel partitioning called cold division multiplexing. In the human analogy, this roughly translates to the asking the couples to speak in different languages. The idea there is you're so tuned in to a particular language that you can filter out the other languages. In CDMA as well as in real life, if the background noise becomes too much, even if they are speaking in different languages, still you will not be able to receive properly. So here in CDMA, each sender is assigned a different code, and sender can transmit in the entire frequency band all the time. So this is kind of a very fascinating thing. In that, a sender is using the entire frequency band and he's transmitting all the time, and still this does not cause collisions. The fact that a sender is using the entire frequency band, which gives R bits per second, doesn't mean the sender, when there are n other users, everyone will receive R bits per second. When there are n senders, the achievable rate is still R over n. And this also suffers the same problems as with previous protocols. In other words, if you give dedicated access to a resource, then if others are not using it, you're going to waste the resource. So you must be wondering, what is this code and what property does it have that it permits that even when people are transmitting at the same time, they can still not collide with each other. I personally find CDMA very fascinating. So let me show you how things work. So here is the case of CDMA with the single sender. Here is the code that I was talking about. So this code is 8 bits, 1 1 minus 1 minus 1 1 1 minus 1 minus 1. And here is the data. The 0 bit is represented as a negative voltage and the 1 bit is represented as a positive voltage. So if you want to send this data 0 bit, all you do is you multiply this data with the code bits. So as you can see here, because this is minus 1, all the bits are flipped. So you have minus 1, minus 1, 1, 1, minus 1, minus 1, 1, 1. Since this is plus 1, and the code when you multiply it with will result in the same code. So this is 1, 1, minus 1, minus 1, 1, 1, minus 1, minus 1. So this is what is going to be received by the receiver. And this is the receiver code sequence, which is the same as the sender code sequence. This helps you to recover the data bits. So what you do is you're just going to multiply the received signal with the receiver code sequence. So what you're going to do here is basically minus 1.1 plus, this is again minus 1.1 plus 1 dot minus 1, so on. So there are 8 such terms and you're going to take an average of it, and this, as you see, is going to be equal to minus 1, which is actually the data bit. By the way, this 8 comes about because there are 8 bits as part of the code. So this is a simple case. The more interesting case is when there are 2 senders. How do you ensure they still do not collide? So in this case, there are 2 senders, sender 1 and sender 2. Sender 1 is sending minus 1, 1, whereas sender 2 is sending 1, 1. So sender 1 has this code sequence and sender 2 has this code sequence. As you can see, the code sequence is not the same. These codes are orthogonal codes. That is a property of CDMA codes. Just like before, you're going to take a product of these both for both sender 1 and sender 2. So that is, this is the product. And then what the channel is going to do is it's going to add them up. So this is what you're going to see here. I will just do one calculations. I will let you do the other calculations. Let's look at this. This is 1 into minus 1. So during this time, this sender 1 is sending minus 1, whereas in this interval, this is also sending minus 1 because that is 1 into minus 1 again. So this is also minus 1. So when you add them up, this results in a minus 2. So we are looking at this position. Now let's look from the perspective of sender 2. So this is the sender's 2 code sequence and this is what it is receiving on the channel. Much like before, it's again going to do a product of what it is receiving on the channel with the code. So this happens to be 1 into 0 plus -1 into -2 plus all the other terms. So this happens to be 2 plus whatever, you have to take an average, and this turns out to be equal to 1. That is what was actually sent. So I will let you do these calculations to convince yourself that each sender can recover the signal even though they are overlapping in time, and this is mainly because of this orthogonal property of the code. The challenge in CDMA is often in deriving such orthogonal codes.